Welcome to the Explainer. If you are serious about running highly capable, completely private AI without sending a single token to a cloud endpoint and, without melting your rig in the process, you are definitely in the right place. Today, we're breaking down exactly how to maximize local AI inference on a single 24 GB GPU in 2026, all based on MarkTechPost's latest guide. Let's get right into it. All right, here's our roadmap for today. We're going to cover the 24 GB sweet spot, explain the strict VRAM math, look at 2026's top 6 local LLMs, acknowledge the models that are just too big to fit, and finally show you exactly how to run them locally.
So let's kick things off with Section 1, the 24 GB sweet spot.
This right here brilliantly illustrates the big shift we've seen in 2026. Remember the old hobbyist trick of cramming a heavily compressed 70 billion parameter model onto your GPU? Yeah, that's out. It used to be a badge of honor, but frankly, it just choked your machine and basically turned your PC into a very expensive space heater. That outdated method has been completely replaced by a much smarter strategy. Now we use right-sized 20 to 35 billion parameter models. These modern models fit beautifully, they leave plenty of room for your context window, and they respond instantly. It gives you the actual speed you need for complex coding, fluid chat, and autonomous agents. Moving right along to Section 2, the VRAM math explained.
Okay, look at this strict memory budget. Think of it like a pie, or in this case, a donut. Your main slice, the biggest chunk by far, is always going to be the model weights. But you can't just stop there. If you don't carve out about 1 to 2 gigabytes for the KV cache, which, by the way, grows the longer your conversation gets, you are going to hit that dreaded out-of-memory error instantly. Literally, a brick wall. Add in a little sliver for your software runtime overhead, and suddenly, wow, that 24 gigabytes doesn't look quite so bottomless anymore, does it?
So the absolutely crucial point here is this magic number, 0.58. At the standard Q4 KM quantization level, which is pretty much the undisputed gold standard for balancing quality and memory in home inference, every single model parameter costs roughly 0.58 bytes. If we do the math, a 32 billion parameter model eats up about 18 to 20 gigabytes of your VRAM just sitting there doing absolutely nothing. This is your baseline equation for hardware in 2026. And honestly, that math leads us right into a massive pitfall that catches a lot of people off guard, the MOE trap. Highly efficient mixture of experts, or MO models, boast incredibly fast generation speeds because only a tiny fraction of their parameters are active at any given time. But here's the catch, the trap, if you will. Every single expert must remain resident in your VRAM just in case it gets called upon. So you must always budget your memory based on the total parameter count, never just the active ones. You can't cheat the math. All right, let's dive into Section 3, 2026's top 6 local LLMs. This overview highlights our top 6 contenders, and each one has a specific superpower tailored to different developer needs. From heavy-duty coding to rich multimodal inputs, think of this table as essentially your 2026 local AI shopping list. Let's break them down one by one, shall we? Starting us off, Alibaba's Qwen 3.627B is hands down your strongest default choice. It uses roughly 16 gigabytes of VRAM at our standard quantization, which leaves a massive 8 gigabytes of headroom for huge context windows. That extra space is absolutely critical. If you're doing complex, multi-step agentic coding workflows, or say analyzing entire code repositories, this is the absolute workhorse you want chugging away on your machine. Now, if pure speed is your primary goal, you've got to consider its sibling, the 35B A3B. Because it uses a mixture of experts architecture, it is incredibly fast. I mean, only 3 billion of its 35 billion parameters actually fire at once during generation. However, remember our MOE trap from earlier? Yep, all 35 billion parameters still have to sit in memory. So this means it's going to be a tighter 20 gigabyte squeeze on your VRAM. But honestly, the blazing fast generation speeds for general chat and tool use make it entirely worth it. Then we have Google DeepMind's fully open Gemma 426B. This release brings serious multimodality directly to your desktop. It actually gives you deep vision inputs, meaning it can natively see and analyze images, right alongside broad coverage across more than 140 languages. And the best part? All of this fits into a very tidy 18.1 gigabyte package. Pretty amazing. For your everyday tasks, Mistral Small 3.2 is an incredibly polished 24 billion parameter dense model. What makes this one really stand out is that it offers the lightest footprint on our entire list at around just 14 gigabytes. Why does that matter? Because it frees up a massive 10 gigabytes of headroom for enormous context lengths. So if you need an assistant to literally read through hundreds of pages of documents all at once, this is absolutely your model. Next up is a really fascinating entry, OpenAI's GPT-OS20B. This is a 14GB open-weight option that offers strong, structured reasoning straight out of the box. What's super unique here is that it ships natively in a highly efficient MXFP4 4-bit format. It is fantastic as an easy fallback for tool use and structured logic, even if it does trade away just a tiny bit of broad world knowledge to achieve that wild efficiency. Finally, for the absolute toughest logic puzzles, the DeepSeek 32 billion parameter distillation model is completely unparalleled. It's your tightest fit, pushing right up to that 18 to 20 gigabyte mark, but it offers an unmatched, fully visible chain of thought process. You can literally watch the model think through visible reasoning tokens. It's slow, it's deliberate, and honestly, it is absolutely brilliant for complex mathematical or logical problem solving. Okay, moving on to section 4, models too big to fit. Just look at this sheer, staggering scale of these frontier models. We are looking at trillion-parameter server-class behemoths like Moonshot's Kimi K2.7 and DeepSeek's V4 Pro. I mean, they are engineering marvels, but they are a stark reminder that for massive, sparse MOE systems of this scale, you will absolutely need to rely on API alternatives instead of your desktop rig. They are great to know about, for sure, but they don't change our 24GB local strategy. Which brings us to our final section, Section 5, how to run them locally. You essentially have 3 execution tiers here. If you want a model running in 60 seconds with 0 headaches, a Llama is your plug-and-play, easy button. Literally foolproof. Now, if you're a bit of a control freak who wants granular command over exactly which files and offloads are happening, well, Llama CPP is going to be your best friend. And lastly, if you're building an app where multiple users are going to hammer your local model simultaneously, you'll need to bring out the heavy artillery of VLLM's concurrent server architecture. So, armed with the precise VRAM math, the top-tier software tools, and the ultimate 2026 local model roster, the only question left is this: what breakthrough application will you build on your own private local hardware today? The power is literally sitting right there on your desk. Thank you so much for joining me on this explainer, and I absolutely can't wait to see what you create.